Welcome. This demonstration is brought to you by Digital Den. In part 1 of this blog series, you manually deployed a highly available virtual private cloud that spanned 2 availability zones, setting the foundation for a resilient infrastructure. In part 2, you will now create a scalable and highly available environment for your web server. You will focus on using AWS services to configure high availability. You will start by creating an application load balancer. This essential component distributes traffic across multiple instances, offering inherent high availability and increasing the resilience of your system. Next, you will create a launch template which will streamline the launch process of EC2 instances through an auto-scaling group. By defining crucial instance details such as the desired Amazon machine image, instance type, key pair, and security group, you'll have greater control and flexibility when deploying your applications. In order to enforce a secure 2-tier architecture, you will then configure the security groups appropriately. By separating the tiers, you ensure that your application's security is robust and meets best practices. With your web server now running, you will put its high availability to the test. You will have the opportunity to confirm that your web server is running smoothly and resiliently, even under potential failure scenarios. You will then intentionally terminate one of the EC2 instances to demonstrate the effectiveness of your high availability configuration. Next, you will explore a convenient and secure way to connect to an EC2 instance in a private subnet using the EC2 Instance Connect endpoint. Once connected to an instance, you will then initiate a stress test on the web server CPU, and witness how your infrastructure dynamically scales out to meet increased demand, ensuring optimal performance during peak times. In Task 1, you will create an application load balancer. To build a highly available application, it is a best practice to launch resources in multiple availability zones. Availability zones are physically separate data centers in the same region. If you run your applications across multiple availability zones, you can provide greater availability if a data center experiences a failure. Because the web server runs on multiple servers, you will need a way to distribute traffic amongst those servers. You can accomplish this goal by using a load balancer. This load balancer will also perform health checks on instances and only send requests to healthy instances. Navigate to the EC2 console, and in the left navigation pane, choose Load Balancers. Choose Create Load Balancer. A few types of load balancers are displayed. Under Application Load Balancer, choose Create. For load balancer name, enter Web Server LB. Scroll down to the Network Mapping section, then for VPC, select Web Server. This VPC was created in part 1 of this blog series. You will now specify which subnets the load balancer should use. It will be a public load balancer, so you will select both public subnets. Under Mappings, choose the first availability zone, then choose the public subnet one. Choose the second availability zone, then choose the public subnet 2. In the Security Groups section, select the Create a New Security Group hyperlink. This opens a new browser tab. For security group name, enter Web Server LB. For description, enter Enable Web Access to Load Balancer. For VPC, remove the default VPC by choosing the X to the right of it. Then select Web Server. Under Inbound Rules, choose Add Rule, and for type choose HTTP. For source, choose Anywhere IPv4. Choose Add Rule again, and now add a rule for HTTPS. For type, choose HTTPS. For source, choose Anywhere IPv4. Choose Create Security Group. Next, assign the security group to the load balancer. Return to the Browser tab where you are still configuring the load balancer. In the Security Groups area, and choose the refresh icon. For security groups, select the web server LB security group you just created. Below the security groups drop-down menu, select the X next to the default security group so that web server LB is now the only security group chosen. In the Listeners and Routing section, choose Create Target Group. A new browser tab will open. Target groups define where to send traffic that comes into the load balancer. The application load balancer can send traffic to multiple target groups based upon the URL of the incoming request, such as having requests from mobile apps going to a different set of servers. Your web server will use only one target group. For choose a target type, select Instances. For target group name, enter web server app. For VPC, ensure that web server is chosen. Scroll down and expand Advanced Health Check settings. The application load balancer automatically performs health checks on all instances to ensure that they are responding to requests. The default settings are recommended, but you will make them slightly faster for use in this demo. For healthy threshold, enter 2. For interval, enter 10 seconds. The configurations you have chosen will result in the health check being performed every 10 seconds, and if the instance responds correctly twice in a row, it will be considered healthy. Choose Next. The Register Targets screen appears. Targets are the individual instances that will respond to requests from the load balancer. You do not have any web application instances yet, so you can skip this step. Review the settings and choose Create Target Group. Return to the Browser tab where you already started defining the load balancer. In the Listeners and Routing section, choose the refresh icon. For the listener HTTP 80 row, set the default action to forward to the web server app target group you just created. Scroll to the bottom of the page, and choose Create Load Balancer. The load balancer is successfully created. Choose View Load Balancer. In Task 2 you will create a launch template to facilitate the launch of EC2 instances by an auto-scaling group. The launch template allows you to define important instance details, including the desired Amazon machine image, instance type, key pair, and security group. If you already have a web server configured to your requirements, you can create an Amazon machine image of it. This process captures a snapshot of the root volume, preserving all necessary files, settings, and software installations. By creating an AMI, you can retain the exact state of the web server's operating system and configuration. As part of this demo, you will incorporate a user data script in the launch template instead. This script will be executed automatically during instance launch, enabling you to install and configure an Apache web server. This ensures that the launched instances are ready to serve your web pages effortlessly. Navigate to Launch Templates and choose Create Launch Template. For launch template name, enter Web Server LT. Under Auto Scaling Guidance, select Provide Guidance to help me set up a template that I can use with EC2 Auto Scaling. In the Application and OS Images area, choose Quick Start and then select Amazon Linux. For Amazon Machine Image, choose Amazon Linux 2023 AMI 2023. If you had an existing web server, you could create an image of it, which would save the contents of the root volume of the web server so that new instances could be launched with an identically configured guest operating system. For instance type, choose T2.micro. For key pair name, choose Don't Include in Launch Template. For security groups, choose Select Existing Security Group. Then choose the Web Server SG. Scroll down to the Advanced Details area and expand it. Scroll down to the Detailed CloudWatch Monitoring setting and select Enable. Under User Data, paste in the user data script found on my blog, the link to which can be found in the comments sections below. This script installs Apache Web Server, downloads a zip file containing the website files, extracts the website contents into the appropriate directory, and then cleans up the temporary folder. The end result is the deployment of your website on the Apache Web Server. Choose Create Launch Template. In the Success dialog, choose the Web Server LT Launch Template. Next, you will create an auto-scaling group that uses the launch template that you created in the previous step. The auto-scaling group defines where to launch the EC2 instances. In Task 3 you will create an auto-scaling group. Amazon EC2 Auto-Scaling is a service designed to launch or terminate Amazon EC2 instances automatically based on user-defined policies, schedules, and health checks. It also automatically distributes instances across multiple availability zones to make applications highly available. In this task, you will create an auto-scaling group that deploys EC2 instances across your private subnets, which is a security best practice for application deployment. Instances in a private subnet cannot be accessed from the internet. Instead, users send requests to the load balancer, which forwards the requests to EC2 instances in the private subnets. On the Web Server Launch template from the Actions menu, choose Create Auto-Scaling Group. For auto-scaling group name, enter Web Server ASG. For launch template, confirm that the Web Server LT template you just created is selected. Choose Next. For VPC, choose Web Server. For availability zones and subnets, choose Private Subnet 1 and Private Subnet 2. This will launch EC2 instances in private subnets across both availability zones. Choose Next. In the Load Balancing panel, choose Attach to an existing load balancer. For existing load balancer target groups, select Web Server App. In the Health Checks panel, for health check grace period, enter 90 seconds. In the Additional Settings panel, select Enable Group Metrics Collection within CloudWatch. This will capture metrics at 1-minute intervals, which allows auto-scaling to react quickly to changing usage patterns. Choose Next. Under Group Size, for desired capacity, enter 2. For minimum capacity, enter 2. For maximum capacity, enter 6. With this configuration, your auto-scaling group will maintain a minimum of 2 instances and scale up to a maximum of 6 instances based on the demand and load on your application. The auto-scaling group will automatically add or remove instances as needed to keep the number of instances within the specified range. Under Scaling Policies, choose Target Tracking Scaling Policy. For metric type, choose Average CPU Utilization. For target value, enter 25. For instances need, enter 60. The target tracking scaling policy is configured to maintain the average CPU utilization of a target group at a specific value. In this case, the target value is set to 25%. When the average CPU utilization of the instances in the target group exceeds this target value, the policy takes action to scale up the number of instances. Choose Next. You do not need to configure any notifications. Choose Next. Choose Add Tag. For key, enter name. For value, enter Web Server. These settings will tag the auto-scaling group with a name, which will also appear on the EC2 instances that are launched by the auto-scaling group. You can use tags to identify which Amazon EC2 instances are associated with which application. You could also add tags such as Cost Center to assign application costs in the billing files. Choose Next. Review the details of your auto-scaling group. At the bottom of the page, choose Create Auto-Scaling Group. The group currently has no instances, but the status column indicates updating capacity. The desired quantity is 2 instances. Amazon EC2 auto-scaling will attempt to launch 2 instances to reach the desired quantity. The min is set to 2 instances. Amazon EC2 auto-scaling will try to always provide 2 instances, even if a failure occurs. With a maximum capacity of 6, the auto-scaling group should not exceed 6 instances, even during high demand periods. Your web server will soon run across 2 availability zones. Amazon EC2 auto-scaling will maintain that configuration even if an instance or availability zone fails. After a minute, choose the refresh icon to update the display. It should show that 2 instances are running. In Task 4 you will update the security groups. The application you deployed is a 2-tier architecture. You will now configure the security groups to enforce these tiers. You already configured the load balancer security group when you created the load balancer. It accepts all incoming HTTP and HTTPS traffic. The load balancer has been configured to forward incoming requests to a target group. When auto-scaling launches new instances, it will automatically add those instances to the target group. You configured the web server security group in part 1 of this demo. You configured a rule to allow incoming HTTP traffic from any IPv4 source. You will now configure it to only accept incoming traffic from the load balancer. On the EC2 console in the left navigation pane, choose Security Groups. Select Web Server SG. In the lower half of the page, choose the Inbound Rules tab. Choose Edit Inbound Rules. Choose Delete. By removing the HTTP rule that accepts traffic from anywhere can be considered a better security practice. By doing so, you are reducing the attack surface and restricting access to your security group to only the necessary sources. You will now add a rule to accept incoming HTTP traffic from the load balancer. You do not need to configure HTTPS traffic because the load balancer was configured to forward HTTPS requests via HTTP. This practice offloads security to the load balancer, reducing the amount of work that is required by the individual application servers. On the Edit Inbound Rules page, choose Add Rule and for type choose HTTP. For source, enter SG. From the list that appears, select Web Server LB. For description, enter traffic from load balancer. Choose Save Rules. The web servers can now receive traffic from the load balancer. This includes health checks that the load balancer performs automatically. In Task 5 you will test the web servers. First, you will confirm that your web server is running. You will also test that it is highly available. From the EC2 console, in the left navigation pane, choose Target Groups. Select Web Server App. In the lower half of the page, choose the Targets tab. This tab should show 2 registered targets. The health status column shows the results of the load balancer health check that is performed against the instances. In the registered targets area, occasionally choose the refresh icon until the status for both instances appears as healthy. You will test the web server by connecting to the load balancer, which will then send your request to one of the EC2 instances. You will first need to retrieve the domain name system name of the load balancer. In the left navigation pane, choose Load Balancers and then choose Web Server LB. In the Details tab in the lower half of the window, copy the DNS name to your clipboard. Open a new web browser tab, paste the DNS name from your clipboard and press Enter. The load balancer forwarded your request to one of the EC2 instances. Your web server displays. You sent the request to the load balancer, which resides in the public subnets that are connected to the internet. The load balancer chose one of the EC2 instances that reside in the private subnets and forwarded the request to it. The EC2 instance then returned the web page content to the load balancer, which returned it to your web browser. In task 6 you will test high availability. Your web server was configured to be highly available. You can prove the web server's high availability by terminating one of the EC2 instances. You will now terminate one of the web server instances to simulate a failure. Navigate to your instances. Select one of the web server instances. Choose Instance State. Terminate Instance. Choose Terminate. In the left navigation pane, choose Target Groups. Select Web Server App. In the lower half of the page, choose the Targets tab. In a short time, the load balancer health checks will notice that the instance is not responding. The load balancer will automatically route all requests to the remaining instance. Return to the Web Server tab in your web browser and reload the page several times. Though an instance failed, your web server remains available. After a few minutes, Amazon EC2 auto-scaling will also notice the instance failure. It was configured to keep 2 instances running, so Amazon EC2 auto-scaling will automatically launch a replacement instance. Return to the EC2 console tab where you have the instances list displayed. In the top right area, choose the refresh icon every 30 seconds or so until a new EC2 instance appears. After a few minutes, the health check for the new instance should become healthy. The load balancer will resume sending traffic between the 2 availability zones. Navigate back to your instances. Click Refresh to confirm there are 2 healthy instances. This task demonstrates that your web server is now highly available. In Task 7 you will connect to an EC2 instance in a private subnet using EC2 Instance Connect Endpoint. Traditionally, connecting to these instances required setting up a Bastion host with a public IP address over an internet gateway in your VPC, along with port forwarding and additional configuration. However, with the EC2 Instance Connect Endpoint, you can establish direct connections to your instances and other Amazon VPC resources from the internet without the need for a Bastion host, a public IP address, or additional agents. This streamlined approach simplifies connectivity, enhances security, and eliminates the complexities and potential risks associated with the traditional method. In order to use Amazon EC2 Instance Connect Endpoint for SSH access to your instances, you need to have port 22 SSH open in the security group associated with your instances. This allows the SSH traffic to reach your instances through the EIC endpoint. Navigate to Security Groups. Select Web Server SG. In the lower half of the page, choose the Inbound Rules tab. Choose Edit Inbound Rules. Choose Add Rule and for type choose SSH. For source choose Anywhere IPv4. For description enter Allow SSH access via EIC endpoint. Choose Save Rules. Next you will create the EC2 Instance Connect endpoint. Navigate to the VPC console and in the left navigation pane, choose Endpoints. Choose Create Endpoint, and then for name tag, enter Web Server Endpoint. For service category, choose EC2 Instance Connect Endpoint. For VPC, select the web server. For security groups, select Web Server SG. For subnet, select the private subnet 1. Choose Create Endpoint. The initial status is pending. Before you can connect to an instance using this endpoint, wait until the status is available. This can take a few minutes. Next, connect to your EC2 instance in private subnet 1 using the Amazon EC2 console. Navigate to the EC2 console, and in the navigation pane, choose Instances. Select the web server instance that resides in private subnet 1, and choose Connect. Choose the EC2 Instance Connect tab. For connection type, choose Connect using EC2 Instance Connect Endpoint. For EC2 Instance Connect Endpoint, choose the web server endpoint. Choose Connect to open a terminal window. Leave this open as you will perform a stress test on this instance in the next task. In task 8 you will test automatic scaling under a load. You will test whether the web server scales out automatically. Refer back to my blog and copy the stress test commands to your clipboard. Paste the commands from your clipboard to the web server instance. This command installs the extra packages for Enterprise Linux repository on your system. It then installs the stress package, which is a tool used for generating CPU, memory or disk stress on a system. This test will stress one CPU core for 600 seconds, during which the auto-scaling group deploys new instances. Observe the Amazon EC2 console. During the test, you should observe that more web server instances are deployed, with a maximum of 6. In the left navigation pane, choose Target Groups. On the web server app in the lower half of the page, choose the Targets tab and select Refresh. This tab should show 5 registered targets. The health status column shows the results of the load balancer health check that is performed against the instances. Navigate back to your instances. Once the stress test finishes and the load on your web server decreases, the ASG will monitor the demand and scale down if necessary. Choose the refresh icon every 30 seconds or so until the EC2 instances terminate. If the number of instances exceeds the desired capacity of 2, the ASG will terminate the excess instances, reducing the capacity to the desired level. Navigate to Load Balancers and copy the DNS name of web server LB to your clipboard. Open a new web browser tab, paste the DNS name from your clipboard and press Enter. Your web server is still running. Congratulations! When traffic increases, the web server now successfully scales out. You have implemented a highly available and scalable architecture for your web server.